Technically, you know everything you need to know to be successful with a problem like this. But I'm going to give you a few examples with missing terms. What do we replace our missing terms with? We replace them with 0. So 2x to the 5th. And the only reason we do that is just to keep us organized. It keeps everything in a nice line. Plus, I'm missing x to the 4th. I'm missing x to the 3rd. X squared. I'm missing 0x. I'm missing my linear term. So I like to do a quick double check at the end. 5, 4, 3, 2, 1, 0. That helps me make sure I have all the missing terms accounted for. Now to make sure these are in descending order, so I'm left with x cubed. I'm missing a squared term. So notice how I do it on the dividend and the divisor. And I like to give my quick divisor a check. 3, 2, 1, 0. So good to go. All right, now we're all set up. See if you can pause the video and go all the way through the rest of this problem. All right, hopefully you were able to finish. 2x to the 5th divided by x cubed is going to give me 2x squared. 2x squared times this is going to give me 2x to the 5th. 2x squared times this is going to give me 0x to the 4th. If you don't feel like writing the x to the 4th and you just want to write it as 0, that's completely fine too. 2x squared times negative 3x gives me negative 6x cubed. 2x squared times negative 4 gives me negative 8x squared. See how they're all in a nice line. Then remember I subtract that entire quantity. 2x to the 5th minus 2x to the 5th is 0. 0x to the 4th minus 0x to the 4th is just 0. 0x cubed minus a negative 6x cubed is just going to give me 6x cubed. 3x squared minus a negative 8x squared is really 3x squared plus 8x squared. So that's going to give me 11x squared. Now, how many terms are in my divisor? Well, there are 4 with the 0 included. So now I need 4 here. I only have 2. So how many do I need to bring down? I need to bring down both of these. So I'm going to get plus 0x plus 12. Okay, now I need to ask myself, 6x cubed divided by x cubed gives me just plus 6. So is that okay that I'm missing a linear term up here? Yeah, I didn't need it. 6x cubed plus 0x squared. 6 times negative 3x, negative 18x. 6 times negative 4, negative 24. Subtract that entire thing. 6x cubed minus 6x cubed is 0. 11x squared minus 0x squared is just 11x squared. 0x minus a negative 18x is just positive 18x. Positive 12 minus a negative 24 is really 12 plus 24, so plus 36. Now, do you guys notice that the degree of this is 2, where the degree of this was 3? Remember, you stop when the degree of your remainder is less than the degree of the divisor. So we're going to stop right here. So I know that my final answer is just going to be 2x squared plus 6. How do I write the continuation of this? Well, I write plus, even if this is a negative here, I'm still going to write plus. Write the remainder as is up here over the divisor. Now, do I need the missing term in the divisor? No. I'm going to write it just like this. So this is my final answer. All right, divide this by this. See if you can pause the video and go all the way through. Save yourself a bunch of room. I'm going to try to write small, but this problem is going to take a little bit of space. So 10x to the 4th minus 3x cubed plus 0x squared plus 5x minus 4. 2x squared minus plus 0x minus 1. 4, 3, 2, 1, 0, 2, 1, 0. All right, now I need to ask myself 10 to the 4th. 10x to the 4th divided by 2x squared is going to give me 5x squared. And then I multiply. 10x to the 4th, 0x to the 3rd, negative 5x squared. Remember, I subtract all of that. I get 0, get negative 3x cubed. 0 minus negative 5 is really plus 5x squared. I have 3 terms here, so I'm going to need to bring down only 1. Now I need to ask myself, what is negative 3x cubed divided by 2x squared? Well, I'm going to get negative 3 halves x. So negative 3 halves x. and I multiply every single term by that quantity. So I'm going to do 2x squared times negative 3 over 2x. So I know I'm going to get x cubed. These cancel, so I'm left with negative 3. 0 times negative 3 halves x is just going to be 0. You can attack on the 0x squared if you want, but either way it's 0. Now I have to do negative 1 times negative 3 halves x. So really that's just going to be plus 3 halves x. Now I subtract that entire quantity. Negative 3x cubed minus a negative 3x cubed is 0. Then I'm left with 5x squared. Now I'm left with 5x minus a positive 3 halves x. So maybe make this 10 halves so I can combine the fractions a little bit easier. So 10 minus 3 is 7. Keep the denominator, keep the x, because they're like terms. Now I want to bring down, because I only have 2 terms here, so I need one more term. And this is degree 2, this is degree 2, so I'm going to keep going. 5x squared divided by 2x squared just gives me 5 halves. So I have my next term in my quotient. So then I do 5 halves times 2x squared. These cancel, I'm left with 5x squared. Now I have to do 5 halves times 0x. Then I want to do 5 halves times negative 1. And I subtract that entire quantity just like always. 5x squared minus 5x squared is 0. 7 halves x minus 0x is just 7 halves x. Negative 4 minus a negative. 5 halves. Remember, get a common denominator. Negative 8 divided by 2 does equal negative 4. So again, we didn't change anything, just how it looks. Negative 3 halves. So I get minus 3 halves here. The degree of this is 1, the degree of this is 2. So now I know where I'm going to stop, and I know that this is my remainder. So how do I write my final answer? I write my quotient plus my remainder. 7 halves x minus 3 halves over my divisor, 2x squared minus 1. Now I see a fraction in this fraction, so I'm going to try to get rid of that. What can I multiply the numerator by to get rid of both those fractions? Well, just 2. I'm not allowed to just randomly multiply a numerator by a number, but I am allowed to multiply a fraction by 2 over 2, because you see how this equals 1. So if I multiply the numerator by 2, this becomes 7x minus 3. What does the denominator become? 4x squared minus 2. So I can go ahead and rewrite my final answer. As this. Now we're going to learn a different type of division. This is called synthetic division. You're able to use this when you're dividing by a linear term where the a is equal to 1. So for example, you wouldn't be able to use synthetic division on here. It would be way too complicated to try. Or here. This is a linear term, but the a value is not 1. So using synthetic division here would not be wise. However, leading coefficient here on the linear divisor is 1. So using synthetic division for this problem would be a good idea. Now, how do you set up synthetic division? You're going to write this in order. Make sure you use your zeros as placeholders. And you're going to write your coefficients out without using the variable pieces. So you're going to write 2, then 0, then negative 1, then positive 3. Now, what do you write in this box right up here? You set this equal to 0 and solve, and you get 1. Now the first step, you're going to bring down that leading coefficient. Underneath this constant, you're going to close out your box. Now, you're going to take this number, 2, and multiply by this number here and get 2. Then you're going to add down. So 0 plus 2 is 2. Then you're going to multiply. 2 times 1 is 2. Then you're going to add down. negative 1, so you're going to combine. Negative 1 and a positive 2 gives you a positive 1. 1 times 1 gives you 1. Combine down, 3 plus 1 is 4. Now that you're here, this is going to be your remainder. This is going to be your constant. This is going to be your linear term. This is going to be your quadratic. If there was another one, it would be cubic, then quartic, etc. So see how I'm going backwards? It helps me figure out how to rewrite it. So this is going to give me 2x squared plus 2x plus my constant of 1 plus my remainder over my divisor. This is my final answer. Would you prefer using long division or synthetic division for this problem if I just said divide this by this? Most students would choose synthetic since this a value is equal to 1. Synthetic division is rather simple to set up. So let's go ahead and divide these quantities. So remember, I write my coefficients. Now this really is 0x to the third, 0x squared, 0x minus 81. 4, 3, 2, 1, 0. So then I have a 0 next, and then a 0, and then a 0, and then a negative 81. So don't forget your zeros as placeholders. You will get the entire problem wrong if you don't include those when needed. Okay, now what do I put in the box? Well, I set this equal to 0 and solve, and I get negative 3. So then I go ahead and bring down my first term. I multiply. 1 times negative 3 is negative 3. I add down 0 plus a negative 3. Think about it as combining them instead. 0 and negative 3 combined gives me negative 3. Negative 3 times negative 3 gives me 9. Combine them, I get 9. 9 times negative 3 is negative 27. Combine them. Negative 27 times negative 3 is a positive 81. Combine them, I get 0. 0. And remember, underneath the constant in this box, that's your remainder. Now I go backwards. This is my constant. This is my linear term. Some people write it as 0, 1, 2, 3. If that helps you, feel free. This is my quadratic term. This is my cubic term. So it's going to be 1x cubed minus 3x squared plus 9x minus 27. If there were any zeros down here, so for example, if this was a 0, this would just be like 0x squared, and I wouldn't have to write this term. All right, now plus my remainder over my divisor. Do I need to write that last part there? No, I do not. What does this mean? Well, it means that x plus 3 is a factor of this. So if I'm having trouble factoring this quartic polynomial, I've guessed that x plus 3 is actually a factor. How do I know it's a factor? Because the remainder is 0. So if I take this polynomial here and I multiply it by x plus 3, I should get x to the 4th minus 81. So I'm just going to show you how using long or synthetic division helps you kind of factor your polynomials. So if I just asked you to factor x to the 4th minus 81, you can say, okay, well, I factored it to x plus 3 times x cubed minus 3x squared plus 9x minus 27. Now this is a cubic polynomial. You cannot use grouping to factor all cubic polynomials, but it works sometimes. So we're going to figure out if this works. So I'll just bring this straight down. Now to figure out if grouping works, I factor out the GCF from here, and I figure out, is there a way to get x minus 3 as a factor here? If there is, I can factor by grouping. If not, I cannot factor by grouping, and I would have to actually just keep guessing more factors like this. So I'm left with x minus 3, which means grouping should work. So I'm left with x minus 3, because I factor that out in front. What am I left with if I factor that term out of the first term? X squared. What am I left if I factor x minus 3 out of the second term? Plus 9. Bring down the x plus 3. We have just factored this as much as possible. So this is the factored form of this polynomial. If I was asking you for the zeros, you would set this equal to 0, you'd get negative 3. Set this equal to 0, you'd get 3. Set this equal to 0, and you get x squared equals -9. Try to take the square root. There are no real number zeros that come out of here, so there's actually only 2 zeros for this polynomial. So if you were to graph this polynomial, you would see that it hits the x-axis only twice. So this is how you use your division to help you find your factored form of polynomials, which helps you find your zeros. Once you have your zeros, it helps you graph it much easier. Now I want to see if you can pause this video and go all the way through this problem, write your final answer in proper notation. Okay, I'm going to get started. 4, 3, 2, 1, 0. 4, 3, missing my x squared term. 1, 0. Now what do I put in this box? Well, I'm going to use synthetic division, not only because it says synthetic division, but because this a value is 1. So I set that equal to 0 and solve, and I get -1. Now I bring this down. 1 times -1, combine, multiply, combine, multiply, combine, multiply, combine. Now that I'm here, I go backwards. So I do my remainder over my divisor, and then I have my constant, my linear term, my quadratic term, and my cubic term. Is this a factor of this? Well, a very simple way to tell is if you use long division and you get a remainder of 0. The nice thing about this problem is it's a linear term that I'm dividing by, and the a value is 1. So I can actually use synthetic division. Can I also use long division? Yeah, long division works every single time. So if I forget how to do synthetic division, I can always fall back on long division. Long division works for every single type of problem. Synthetic division, you only want to use it when you're dividing by a linear term with an a value of 1. It's the simplest way. So what am I really looking for? I'm looking to see if this goes evenly into this. Well, how do I know? If the remainder equals 0, that means it's a factor. So let's see if it is. If I get -1 as my remainder, I know it's not a factor. So I'm going to bring this first term down, multiply, combine, multiply, combine, multiply, combine. Since my remainder is equal to 6, this does not go evenly into this, so I cannot use this to help factor this down into something times something. So the answer for this problem would be no. If it asked you for why, you could say, oh, because the remainder is 6, not 0.